Okay, so this is my coursework for my Mechatronics Systems module. In this video, I'll be trying to simulate point-to-point movement of a 3 degrees of freedom robot moving a box from a conveyor belt 108 degrees and putting it on the other side. Now, because the robot will have 3 degrees of freedom, it means that when given an end effector position with an X and Y coordinate and an angle of orientation that you're going to pick the box up at, there's going to be two possible solutions in which you can reach that spot. One of these we call an elbow up solution and the other one we call an elbow down solution. I'm using an inverse kinematics model so that when we know the end effector's position and the orientation, we're going to be able to calculate all three angles for both possible solutions. Although both of these solutions reach the same spot, we can't really use the elbow down solution as that's going to come into collision with the conveyor belt. So the one on the left is the elbow up and the one on the right is the elbow down. Now I can design the robot in SolidWorks. You can see that I'm setting some measurements here for the second link of the arm. The first link I'm using is 350mm, the second link is 250mm, and the third link is 200mm. Once I've designed all the parts, then I can start to assemble it. Also in SolidWorks, I've modelled a pallet for the boxes to be stacked on, and I've modelled a conveyor belt for the boxes to move down.
Okay, so for this model, I'm moving the blocks from one conveyor belt onto another conveyor belt. If you look at it from the front, you can see that one's a little bit higher than the other one. And if I look at it from the top, you can see that what the block's going to be doing is coming down this conveyor belt on the right. The arm's going to meet in this location, and the blocks are going to teleport over to the other side and come down this conveyor belt. If I look at the script that I've got for this one, we've got two main variables, which is B and S. So B is the number of blocks. In this situation I've got 4, and S is the state. So we're going to be in either one of two states. 1 is when you're picking the block up from the conveyor belt, and 2 is when you're dropping it down on the next one. This is the actual model that I've got for the conveyor belt. So I'm inputting the state into this function here, and what this does is it sets the position for the end effector, as well as the orientation. So it takes in the state as the input, and the output it returns the X value, the Y value, and the orientation in radians, which we're picking the object up. So for the orientation in this first example, we're just going to be picking it up from the side. You can see we've got 0 here and 180 here. What I then do is I then feed these X, Y, and orientation values into another function for the inverse kinematics. So again, we take these as an input, and like I demonstrated earlier, I've got one solution here where we've got 3 angles. And we've also got another solution here for another 3 angles. So one of these is elbow up and the other one's elbow down. I've got an if statement here that says if we're in the first state, we're going to be using the elbow up. Okay, so what we actually do is output these 3 angles into our actual world. So these are the conveyor belts here, and then I've got positions for all 4 blocks. You can see that if I click on one of these blocks, the rigid transformation determines the position in the world of where the block is, and the X, Y, and Z coordinates are going to be the variables that I've created in the script. In the subsystem, this is where I've got my actual arm. So you can see that here I'm passing in one angle, here I'm passing another, and here I'm passing another angle. Okay, so if I run this simulation from the front view, you should be able to see that I'm picking the blocks up from the side, and it's showing the angles for the arm's movement. If I then move to the top, you should be able to see the blocks coming down when we run it. So they're coming down this conveyor belt and moving over to the other side. And then if I finally show it in an isometric view, you'll be able to see a little bit better.
Now we've got each individual part in Simula, we can go ahead and run the model, so we can see that the only force acting upon the arm at the moment is gravity. That's why it's swinging about.
Okay, so for the second task of palletizing the boxes, we're going to look at basically stacking them on top of one another. This is my Simulink model. So again, we've got a function for setting the end effector position of the arm. The variables we're going to put in is which block and which state we're at. However, this time it's a little bit different, as we're going to be grabbing and dropping the box from the top. So you can see I've got it at minus 90 degrees here. And the end effector position is going to be different for each box as we're dropping them on top of one another. We're still going to be outputting the x, y and orientation values into the inverse kinematics function. And one of the differences that I've made to the kinematics model is this time I've actually imported the pallet and the conveyor belt that I've designed in SolidWorks. So if we move across to it, this is what this one's going to look like. Just like last time, the conveyor belt's a little bit higher and then the pallet is below. Okay, so if I run this model from your front, you should be able to see that the end effector position of the arm is different every time it drops the box off on the pallet. It's still picking the box up at 90 degrees and dropping it off at 90 degrees as well. And you can see it stacked the boxes on top of one another. If we look at this from the top, again you should be able to see the boxes moving down the conveyor belt. And finally, if we run it in an isometric view, just to see it properly, you can see it stacked the boxes properly on top of one another.
Now the reason that I haven't implemented the CAD design into the Simulink model is because I'm having a few issues when setting the angles for the arm. You can see that when I've entered some values for the end effector position and the orientation, it's just not reaching that spot. Therefore I made the decision to focus the rest of my time on writing the report for this assignment.